Alright guys, so today's video is going to be a little bit different. As you can see, it's not social med. Social med is driving me crazy. But yeah, I understand a lot of people enjoy it, just because it is a very tough subject and, I'm struggling with it a lot as well, so I do still plan to make more. I might make another one today, depending on time. But today's video, and yeah, so just before I start, I do plan on making other videos from other topics as well, but there will be things that I'm struggling with. Um, so yeah, just wanted to give you a heads up on that. Okay, so today's video is on dyslipidemia and atherosclerosis. Now, dyslipidemia, as in the word dys meaning abnormal, and lipidemia meaning increased fat content in blood or abnormal, right? Reason it's abnormal, you want to say abnormal rather than increased, is because you can have increased LDL, but you can have a decrease in something, and that something is HDL. HDL is responsible as well for kind of good house cleaning, you could say, of the fat metabolism in your body. And alternatively, LDL is responsible for more of the negative parts of fat metabolism. Okay. Now, if we move on to types, right, we can classify this into two types: genetic and underlying. Now, another way you can think of this is primary is hereditary, and secondary is acquired. Now, genetic only has one or two things, which is good. Okay. Now, like I said, this is not going to go. I'm not going to be going into fat metabolism, like the whole structure and diagram and sequences. And so, if you are unsure about some of these things, like apoprotein, receptors, that sort of thing, then it'll be a good job to just have a look at that and then come back. Okay, so with genetic, one major type of genetic abnormality you can have, which runs in families, is familial hypercholesterolemia. Now, what this basically is there is a genetic mutation within a receptor that's located within the liver. Okay. This receptor is LDL receptor, LDLR. Okay. So I've represented it via this blue dot here. And why is this a problem? Why is a mutation in this receptor a problem? The thing is that these lipoproteins, okay, if we want to simplify things, right, we want lipoproteins to go to the liver. Yeah? Because we want to unload these, the cholesterol and the triglycerides, because these things can be broken down. Yeah, the liver is great at breaking down the triglycerides, the cholesterol especially. Cholesterol can be broken down into things like bile, and bile can be, bile salts, and bile is responsible for, emulsification of fats and absorbing fats, which, as you know, makes chylomicrons and etc. etc. Okay, so yeah, so going back to this mutation causes a mutation in the LDL. So what does that mean? This lipoprotein now can no longer bind and now can no longer release the contents to the liver. So what does that mean? There's just going to be more accumulation of lipoproteins. Yeah, they're going to be floating around in our blood. And what does that mean? You're going to get hypercholesterolemia. Okay, so that's that. Now, if you want to know some extra points, then there are different types of hypercholesterolemia. Okay, or dyslipidemia, primary type. Okay, it's type 1, type 2, 3, 4, 5. This one I just mentioned is type 2. So with this one, so why this is bad is because it increases LDL and VLDL. These low density lipoproteins are especially they're especially damaging to the body. Okay, and so yeah, if you want to add another one, then you can do that. Underlying conditions now, secondary type. Now, first type is insulin resistance. Okay. Now, obviously, when I say insulin resistance, diabetes type 2 should come to mind. Now, a lot of people may already know that insulin is responsible for anti-lipolytic function, but sometimes we might just forget what that actually means. Okay, so if we have insulin resistance, right, there is going to be an abnormality, a dysfunction in the lipolytic function. Now, let's just go into this a little bit more. So, within, let's say, an adipocyte, so this yellow structure is an adipocyte. Now, within this adipocyte, you got HSL, which is hormone sensitive lipase. Hormone sensitive lipase. Okay. Now, the job of hormone sensitive lipase is to essentially just break down the fats. Okay. Now, originally, physiologically, this shouldn't be active when insulin binds. All right. So, when insulin binds here, what happens is we inactivate HSL. This allows for the fat to accumulate in the adipocyte. How it does this is through GLUT4. GLUT4. Remember, GLUT4 is responsible within muscles such as skeletal and cardiac, and GLUT4 is responsible within the adipocytes as well. So it's not necessarily a bad thing, yeah, because we do need obviously fats for insulation and ketone formation as well if need be, okay, in the fasting state. Now, what happens is when we have insulin resistance, aka diabetes type 2, there's obviously going to be a resistance. And with this resistance, hormone-sensitive lipase now is going not to be inactivated. Okay, whoops. Let's get that back. Hormone-sensitive lipase, okay. Now, since it is activated now, because the receptor is now resisting the insulin, these fat globules, as you can see from this orange, I should have made it a different color, to be honest. I'll put in pink or purple, whatever it is. This now, the fat globule now is going to be broken down into fatty acids, glycerol. Yeah. Now, these things can't be stored. All right. So what happens? It goes into the blood. So over time, we're just accumulating more fats into the blood because hormone-sensitive lipase is active. And what does that mean? Hyperlipidemia. More lipids are going into the blood, more of these fatty acids. And then, what does this mean? When you have excess lipids going into the blood, okay, I would just mention these things as part of dyslipidemia. You don't have to go too crazy on, explanation. One thing you can form is xanthomas and xanthelasmos. Xanthoma is a general term just describing how these accumulations of cholesterol and these triglycerides, cholesterol, they can accumulate in portions of the skin, and they are seen as these yellow depositions on the skin, and not only the skin but the under areas of the eyes as well. So that's one thing to keep in mind. And obviously the big one, atherosclerosis, which is our next topic, which I will come back to in 1 minute. There's still some things we need to mention. So insulin resistance, that's one big thing. Second, now a lot of people, again, may know that hypoalbuminemia, for some reason, it increases the lipid accumulation in the blood. To be honest, I didn't even know until I started revising this. Why was this the case? Why in hypoalbuminemia, why do we get more lipids in the blood? Right? If you know, then you're gonna pass pathophys. So the reason being is because when you have hypoalbuminemia, this, for some reason, which you don't need to know, the mechanism behind it, but what happens is the hypoalbuminemia causes LPL inhibition. Now, in summary, right, LPL is a receptor that intakes the lipoprotein and it delivers it to either the muscles to be used as energy, right? Because the fats are broken down into acetyl-CoA. The acetyl-CoA then goes into the Krebs, and from the Krebs, electron transport chain, all right? And then the next thing is we have the fats and we have accumulation of our triglycerides. Okay. Now, when you have hypoalbuminemia, this receptor is blocked. So what does that mean? These lipoproteins, okay, they're free to accumulate in the blood. Okay, so more and more are building up in the blood. Okay, and so what does that cause? It causes hyperlipoproteinemia again. Alongside that, the same thing happens with sodium chloride, i.e., a high salt diet, LPL inhibition. Okay, now on top of these secondary conditions that increase hyperlipidemia, you could also have, the general things like modifiable and non-modifiable. Well, we've already discussed non-modifiable a little bit. So non-modifiable could be like age, sex, genetics. We've already discussed genetics. Modifiable is like diet, exercise, and yeah, diet, exercise, alcohol, smoking, that sort of thing. Okay, smoke. So that, in a nutshell, is dyslipidemia. Hopefully, this wasn't too excessive in information, but I think it's a good leeway to go into our second topic, which is atherosclerosis. So when I mentioned before with hyperlipidemia, okay, one of the biggest complications is atherosclerosis. Okay, so with atherosclerosis, okay, it can't just magically happen, right? There are some reasons. There are some groundwork that needs to be made in order for atherosclerosis to occur. Now, this groundwork, you could say, is Virchow's triad. And yeah, this is kind of more related to thrombosis. So just focus on this part. Okay, damage. Where does the damage come from? It comes from hypertension. Okay, that's a big contributing factor to atherosclerosis. But usually, when someone is susceptible to atherosclerosis, they would have some secondary conditions like diabetes, and obviously with diabetes, they would have maybe obesity and things like that, which provoke hypertension. And yeah. So what are the two factors? Modifiable, non-modifiable again, right? So modifiable, age, gender, genetics. Okay. Obviously, when you become older, you're more susceptible. Women have a protective factor, which is estrogen. Genetics, as we said before, linked to familial hypercholesterolemia and other dyslipidemia types. Alright, so non-modifiable is the portion you want to explain yourself a little bit. So again, diabetes. Why is diabetes a cause for atherosclerosis? Well, there's two leeways you can talk about. So it goes like this. Okay. Now, when someone has diabetes, obviously they have a higher proportion of sugar, glucose within their blood, okay? Because it's unable to get into the cells. So because there's a higher portion, the lipid is more likely to bump into it, you could think of. It's more likely to bump into it. So if we visualize, here are some fat globules, some lipoproteins, yeah. There's a lot more lipoproteins in the blood. And we have, I'll make it a bit bigger. More of these, all right. If we have more of these lipoproteins, and let's put it in blue. If we have more glucose, okay, a lot more glucose, it's more likely to interact, right? So, why is this a problem? Well, when these things interact, it can form glycolated or glycolated LDL. Okay. Reason it's LDL and not other types is because, like I said, it's hard to explain because you need to know the fat metabolism, but later down the kilo all the way to LDL. The further down you get, the harder it is, you could say, to get back into the liver. So these things are more susceptible to being deposited in the tissues. Okay, so you'll have more of them. Okay, so now if we have glycosylated LDL, the problem with this is that it's hard for it to bind to it's harder for it to bind to, I think it was LPL. So these glycolized LDL, it finds it hard to bind and get in, right? So like with what we said before, what was it? Like we said with here, these LPL inhibitors, yeah, it's the same kind of mechanism. So don't know why I can't pronounce it. Glycolized LDLs can't enter. Okay, so what does that mean? There is a buildup of LDL, and these LDLs, right, can just accumulate within these subendothelial spaces, wherever they may be. Okay. So that's one point. Second point is more glucose causes more glycosylation of collagen. Now you can think of this as making collagen a bit more magnetic towards LDL. When LDL binds, it's kind of like a glue. It makes it more sticky. And I'm not talking pathophysiologically, I'm just talking visually, so you can imagine what I'm saying. So when this happens as well, more LDL can bind to these subendothelial spaces where the collagen is, and as you can imagine, we have a buildup of lipoprotein. Oh, so that was a bloody mouthful, man. Alright, so other things as well, you can mention gout. Gout as well is a immunogenic substance. So you can imagine again, this immunological reaction and more damage to the subendothelial, which provokes this atherosclerosis response. Homocysteine, it's a toxic substance which it can increase reactive oxidative species and hypertension. Okay. Now let's move on to stages, actually. Okay, so what happens exactly? Now, what happens here is these LDLs, okay, they are deposited in the subendothelial spaces, okay, and once they are deposited, okay, macrophages come and they bind. But why? Why does this happen? How does the macrophage even know that it's there? All right. On the LDL itself, you'll have a marker. Okay. Well, it won't be a marker necessarily, but it'll be abnormal. And these LDLs are oxidized LDLs. So I've just represented it with a flag, and that flag represents oxidation, oxidative LDL. Now, why is it oxidative? So it's oxidative just because it interacts with reactive oxidative species. Now, perhaps these things could come from things like homocysteine or other things released from the immunological response, or it can just interact with free reactive oxidative species in the blood. But nevertheless, we have it there in the subendothelial space. Macrophages come along and they have a specific receptor towards this oxidative LDL, and what they have is a scavenger receptor molecule on the surface, okay, specifically designed to engulf these LDLs with that are oxidized, okay. So what happens? They oxidize it. However, they can't break it down, and so they die. Over time, more macrophages and other white blood cells come through chemokines, and there's just an accumulation of these dead macrophages and an accumulation of lipoproteins. So what do we have? An accumulation of fats, macrophages, neutrophils, and calcium. So you have calcium building up as well. So, well, you can actually call this dystrophic calcification. Okay. Now, through this ongoing process, you get a fatty streak, and over time, through reasons which I don't think we need to know, there's smooth muscle proliferation, and this will lead to a fibrous cap. Remember, all of this is within the subendothelium. All of this is within the subendothelium. Okay, so imagine this fatty streak just building up, cutting off more and more of the lumen. Okay, now when you have a fibrous cap, okay, the smooth muscle has proliferated and formed like this layer on top. Obviously, you'll know what I mean by this more and more. Okay, and what can happen? Two things. Either this ruptures, and well, I think both of these might happen, to be honest. It will rupture and it will cause an embolus. This embolus is basically an atherosclerotic atherosclerotic embolus, which can, deposit wherever and maybe cause ischemia or infarction. And rupturing could cause clot formation as well, because remember, this is still within the subendothelium. And what happens when we break the endothelium, right? There's basically a cascade in which the tissue factor, you could say, tissue factor response, essentially just causing coagulation cascade, and a clot will form, and that's gonna even more just build up and obstruct the vessel, and that can lead to infarction as well. So yeah, that was a bit of a long video. But if you've made it this far, then you're a beast. Yeah, I'm gonna leave it there, and yeah, hopefully you found it useful.